Hi, welcome back. We are going to talk about the dot product. So this is section 8.5. And it's all about the dot product. Now the dot product is one way of multiplying vectors. So when it comes to vector multiplication, just like vector addition, it's a little bit more complicated. And we've got two options. We can use what's called the cross product, and that results in a vector. And that's about all we're going to say about the cross product in this class. In this class, in this section, what we're going to talk about is something called the dot product. And the dot product actually results in a scalar. In other words, a number that has no direction. So why? Well, because there are different ways of combining vectors. And so what the cross product gives us is it actually gives us a vector that is perpendicular to both of the other vectors. And you might be thinking, how is that even possible? Well, you have to think in 3 dimensions. So this actually, it's a 3-dimensional thing. That's why that's not in this class. The dot product, though, the scalar product, is related to the angle between the two vectors. And we're going to talk about that a bit more in a minute. First, I need to talk to you about, let's talk about that. So let's think about two vectors. We've got this guy we'll call A, and we've got this guy that we'll call B. And vector A, think about the angle that vector A operates as alpha. And the angle at which vector B operates is theta. Okay? So I'm going to define the angle between them as theta. And theta is just the angle between the two vectors. So this red guy in here is theta. Okay? So we know we can talk about the cosine of angle theta is the cosine of alpha minus beta. And we've got an identity for that. This is the cosine of alpha times the cosine of beta plus sine alpha times sine beta. Okay, now let's go back to our components. So if we think about the x component of vector A, we know a sub x is equal to the absolute value of, or the magnitude of vector A multiplied by the cosine of the angle that vector A makes with the horizontal. So what? Well, that tells me that the cosine of vector A, the cosine of alpha is equal to a sub x divided by the magnitude of A. And in the same way, we know the sine of beta is equal to b sub x divided by the magnitude, that's not the sine of beta, that's the cosine of beta. But we can also get to the sine of alpha, right? The sine of my angle alpha is my y component of my vector A divided by its absolute magnitude. And the sine of beta is my b component of my vector B, my y component of my vector B, divided by the magnitude of B. So let's rewrite my identity. So now I've got cosine theta is equal to the cosine of alpha, which is ax divided by the magnitude of vector A times bx divided by the magnitude of vector B plus ay divided by the magnitude of vector A times by divided by the magnitude of vector B. And if I do just a little bit more work here, what I see is that the cosine of my angle theta is equal to the product of the x components divided by the magnitude, the products of the magnitudes, plus the product of the y components divided by the magnitude, the products of the magnitudes. And how we usually write this actually is the product of the magnitudes of the vectors multiplied by the cosine of the angle between them is equal to ax times bx plus ay times by. Okay, here's the thing. This is defined as the dot product. It comes up so frequently that it gets a name. So A dot B, and we write it just like that, is equal to the product of the x components plus the product of the y components. And that is also equal to the product of the magnitudes of the vectors multiplied by the cosine in between them. So that is the definition of the dot product. This is the first takeaway for this chapter. So I'm going to come back in the next video and we're going to find some dot products and then we're going to solve some problems. So I'll be back in a minute.